Hello everyone. We will be discussing the a priori algorithm under the fuzzy association rules. To explain this algorithm, we will be taking the help of a numerical example. In this example, we can see that there are 12 transactions happening, and in each transactions, there are multiple products which are being sold. Like, for example, in the first transaction, items such as milk, egg, bread, and butter are being sold, right? Similarly, in second example, we can see milk, butter, egg, ketchup. Again, in third example, bread, butter, and ketchup. So similarly, and it goes on till the 12th transaction. Now, in this example, we will find how is the affinity among the different products. Among the different products means among milk, between milk and egg, milk and bread, milk and butter. Similarly, between egg and milk, egg and bread, again egg and butter, and like this. So for this we need the association rules. Now the rule is such that the association rule is a mapping from x to y, okay, where x and y are the items or group of items in the transactions. Now, to explain the a priori algorithm, there are two things that we need to have. One is support, another is confidence. If you see the formula of support, in support, the formula is given by frequency of xy by n. Here n represents the number of transactions. So n is equal to 12 and frequency of x comma y. So here we are we are bothered about the how is the relationship between the group of items or item x with item or group of items y. Okay, this is the support with, so this frequency of xy with respect to total number of transactions, that is giving us a support. Whereas if we see confidence, confidence is given by frequency xy with respect to frequency of x. Say for example, we want to calculate milk and the group of items, say egg, bread, and butter. Egg, bread, butter together represents y, and x is milk. So association of milk with the rest is in the numerator, and in the denominator comes frequency of x, that is say x is milk, frequency of milk. So this is how we go with the a priori algorithm exercise. Next, we will be doing the grouping among the different item sets. So firstly, we will be having a single item set. Secondly, we will be having a two item set, and thirdly, we will be having a three item sets. And after that, we will be grouping the most frequent occurring item sets. Say from the one item sets, we will be having the frequent one item sets. Similarly, from two item sets, we will be having a frequent two item sets, and from three item sets, we will be having the frequent three item sets. Okay, so if you see in the previous table 1 to 12, so there are 12 transactions, right? So how many times is milk occurring in the 12 transactions? This is 1, 2, 3, then 4, 5, 6, 7, 8, 9, right? So here you can see that the milk frequency is 9. Similarly for bread, bread is occurring under 10 transactions, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So here it is occurring under 10 transactions. Similarly, butter also under 10 transactions. Egg under 3, ketchup under 3, and cookies under 5. So after this, the frequency of items are calculated, we select the most frequent items. from the one item sets. So this is 9, 10, 10, 5. Similarly, from the two item sets, we group them: milk, bread, milk, butter, milk, cookies. Again, bread, butter, butter, cookies, and bread, cookies. Now, the question arises that although there are items such as egg, ketchup, cookie, egg, ketchup, so many other items are there. In these two item sets, why am I considering only milk, bread, butter, and cookies? Because we have already understood from the frequent one item sets that these four are the items that are occurring. Now, again, another question arises that how can, on what basis can we say that these are the most frequent items, right? My egg and ketchup is also there. The way that I can say this is the most frequent these are the most frequent item is based on this support level. It is 30% and the confidence level. So the support level is 30%, right? And support is given by frequency of xy by n. We have already seen it. So we are having 12 transactions. So what is the this support of milk? It is 9 divided by 12, which is one third, right? uh, yes, one third. Then egg is how much? 3 by 12, which is one fourth, means 0.25. There is 25%. Now 25% is less than 30%. That's why we are not choosing neither egg nor ketchup. We are going with 9, 10, 10, and 5. 5 is also, if you see, 5 by 12. It is also more than the 30%, right? So this 9, 10, 10, 5. So these are the four cases that we are having. So 9 by 12 is 75%, then 10 by 12, then 5 by 12, right? Similarly, for the two items, based on these four frequent four one item sets, we are taking the items in the two item sets: milk, bread, milk, butter, milk, cookies, and bread, butter, bread, butter, cookies, bread, cookies. So these four items are there in the two item sets. And again, we do in the same procedure. We calculate the frequencies and we select the most frequently occurring two item sets. So if again here the support minimum is 30%, so that's why it is 3 by 12. We are excluding them. We are going with 7, 7, 9, and 4. So these are the four cases, right? Similarly, when we take these four cases, we get the three item sets, these four cases. And from there we can see that the only 6 by 12 crosses the 30% support level. That's why from the frequent three item sets is milk, bread, butter is we are having in the frequent three item sets. Now we have to set the fuzzy association rules. How we do it? We have to create the subsets first. So my initially three item subset is milk, bread, and butter, right? The non-empty subsets are what? Milk, bread, butter individually, then again milk, bread, milk, butter, and bread, butter. Right. Now for every non-empty subset S of I, the association rule is S, a mapping from S to I minus S. So what is my S here? S is my support, right? So support to I is my entire subset, and I minus that this set. So if S is a milk, okay, if S is my milk, then association of milk with whom? This I minus S is what? Say I is my milk, bread, and butter. So if S is milk, so milk, bread, butter minus milk gives me association of milk with bread, butter. Milk, bread, butter minus milk is bread, butter only, right? So mapping from milk to bread, butter. And the rule is valid. So like this we can frame all the rules. Now the rule is valid if the support I by support S is greater than equal to the minimum confidence. So the given conditions are minimum support equal to 30% and minimum confidence is 60%. So I have to satisfy both the things. Firstly, we have seen this minimum support value as 30%. We have already grouped them. Now we have to satisfy the minimum condition case. So for the rule 1, milk to bread butter, it gives support as 6 by 12 is 50%, right? And confidence we have support of milk, bread, butter, that is I by I minus S. So I is my milk support of milk, bread, butter divided by support of milk. So 6 by 12 by 9 by 12. So support of milk, if we see the this case, it's like milk is 9 times, right? And this one when we are getting support of milk, bread, butter. This milk, bread, butter is 6, right? So 6 by 12 by 9 by 12, which is 67%, which is definitely greater than 60%, and hence it is a valid rule. Similarly, for the second rule, we again have a mapping from bread to milk butter, and we get it as 60% exactly. So it is greater than equal to 60%, obviously, and the rule condition says, and hence it is also a valid rule. Next, the third is a mapping from butter to milk and bread. Again, it is 60% similarly. Again, is a valid. Next, milk bread mapping to butter. So milk bread give map to milk bread butter minus this milk bread, which is butter. Mapping from milk bread to butter, which is 85.7% and greater than 60%. Valid, again valid. Similarly, for rule 5, from milk butter mapping to bread, which is 85.7%, and definitely it's greater than 60%. Hence again it is a valid. Finally, mapping from bread to butter, bread butter to milk. So mapping from bread butter to milk, here the support is again 50% and confidence is this support of milk, bread, butter by support of bread butter, which is 6 by 12 by 9 by 12, which is again 67%. Okay, so with this we conclude the this entire thing, the explanation on the a priori algorithm. I hope it is clear to you all. Thank you.